going to look at some circles and their equations. So a circle is all of the points that are the same distance from a fixed center point. So say that I have a circle that has its center at the point 2, -3, and a radius going out in all directions of 2 units. Okay, so what the equation of this circle is going to look like is x minus the x-coordinate of your center point squared plus y minus the y-coordinate of your center point squared. So y minus -3 squared equals your radius squared, which my radius is 2, so that'll be equal to 2 squared. If I kind of simplify it, it looks like x minus 2 squared plus, and then since minus negative gives me +3, equals 4. So it kind of is derived from the Pythagorean theorem, but that's what equations of circles look like. So if I'm doing this one and writing its equation, I'd want x minus -1 squared plus y minus 2 squared equals my radius of 3 squared, and then just simplify. If I am going to graph it, I would probably plot my center point at -1, 2 first, and then count out 3 units, and then plot those points that are on my circle. Connect it, and if you press and hold in Notability, it'll turn it into a nice circle for you now. So there's my circle. Really, the center is not a point on the circle, I just used it to get my drawing, so I'm going to erase it. The equations we've looked at and have been writing have been in center radius form because it makes it easy to find your center and your radius. They aren't always given to you in that form though, so I'm going to take one and turn it into center radius form. Currently this one's in standard form, so this is going to involve some completing the square to get those quantities squared. So I'm going to look at my variables one at a time here. So if I look at my x's, I have x squared minus 6x. If I think about what number of units it's going to take to complete that so that I can turn it into something that factors as a perfect square, I could draw a little sketch of it. I like to draw my picture. So I've got x squared. If I take and make a square, I'm going to have to split that 6x in half and have 3x units on each side. And then 3 times 3 would give me my corner that I need to complete is 9 units. Make sure you add that to the other side of your equation as well. And then that will factor into x minus 3 squared. If you look at your y's, they already factor into a perfect square if you use that 25 units that you have. So you don't really have to complete the square on that part. You can just rewrite it in factor form as y plus 5 squared. So my equation of my circle in center radius form looks like that. And it has its center at 3, -5. If you think about y minus the y-coordinate of your center, that's minus -5. And then your radius squared is 9, which means that your radius itself is 3 units. Okay, let's look at another one. So if I try putting this in center radius form, I'm going to have to complete the square on my x's and my y's because that 29 is not the right number of units to complete the square on either one of these. So I'm actually going to go ahead and subtract 29 from both sides. Be like, yeah, okay, not the right number of units. Let's get the right number of units to complete each of those squares. So if I use my x's, I'll have x squared plus 10x plus, if you think cut 5 in half and then square it, plus 25 will give you x plus 5 squared. Don't forget to add that 25 to the right-hand side of your equation as well. Similarly on my y's, if I cut that -4y in half, it gives you -2 times itself gives you 4 units to complete that square. So on the right-hand side of my equation, I've got -29 plus 25 plus 4, which actually gets me 0. So if I tried to put this in center radius form and I get a result of 0 for my radius squares, that means my radius itself is 0. And this really isn't a circle. It's just a single point at -5, 2, because I'm not going any distance out from the middle. Okay, so this is a little reminder if you're completing the square and your coefficient on your squared term is not 1, you're going to need to divide both sides of your equation or multiply it by whatever it takes to make that coefficient 1. So if you look at these, I went ahead and I rearranged this a little bit so all my x terms are together and all my y terms are together. I have coefficients of 2 on my squared terms, so I'm going to need to divide both sides of this equation by 2 before I complete my square. So that'll give me x squared minus 3x plus 1y squared plus 5y equals negative 19 over 2. And then I'm going to work on my completing the square part so that these will factor as perfect squares. So if I'm completing my square here, I've got x squared and then negative 3x, which I'm going to have to split in half, so that'll be negative 3 over 2x. And then if you are completing your corner, let me label my dimensions here real quick. You have this area in the corner is 3/2 by 3/2, which is going to give you 9 over 4. Don't forget that you're going to have to add that to the right-hand side of your equation as well, because it's an equation. We got to keep it balanced. If we do similarly here, for my square, I'm going to have y squared, and then 5 over 2, and then this would be 5/2 times 5/2, 25 over 4. So if we do a little bit of factoring and rewriting it in form of like side length times side length, if I look at my picture, I'm going to have x minus 3/2 squared plus y plus 5/2 squared equals, if I add these things together on the right-hand side of my equation, that'll just add up to negative 1. Now, if you think about what that says, you're like, okay, it's a circle with a center of 3/2, negative 5/2, and a radius of, wait a second, that says r squared. My radius squared is negative 1, which would mean if I was to actually try to find my radius by taking the square root, I'd have plus or minus I. So actually, this is not a circle. It's not really a graph of any points at all because I cannot plot points that are an imaginary number of units away from my center on the real coordinate plane. So the graph is really non-existent, is what we would say in that case.